Hi again, this is the second lesson for section 2.4, and on this equation I'm going to clear the decimals because I think it's just going to make it easier in the long run. So to clear the decimals, because each one has two places after the decimal, which is the hundredths place, we can multiply everything times 100 on both sides. And so when I multiply 0.12 times 100, it just becomes 12. And then that's what I'll distribute with y minus 6. And then this will be 6y on the second term. Well, the last term on this side, I guess. And then I have 8y minus 70. Remember, we moved the decimal two places to the right in order to clear the decimals in this case because we're multiplying by 100. Now I'm going to distribute the 12. All right, so 12 times y would be 12y. 12 times negative 6 is negative 72, plus 6y equals 8y minus 70. We have to combine the 12y and the 6y on the left-hand side, and that's going to be 18y minus 72 equals 8y minus 70. Now I'm going to get the like terms on the same side, so I need variables on one side, numbers on the other. I'm going to subtract 8y, and that gets rid of the y on the right and gets my like terms of the y's on one side. Now I'm going to add 72. We'll go over here where we have a little more room. And so now I have 10y equals 2 whenever I add negative 7 to 72. Divide by 10, and y equals 1/5. Oh no, we want it in decimal form, which would be 0.2 in this case, because I was dividing 2 by 10, so that becomes 0.2. All right, next. So on this one, we can also clear the decimals because it's to the tenths place. So if I multiply everything times 10, now I like doing this because it's easier for me to do without a calculator if I clear the decimals. It's not a requirement. You don't have to do this. If you want to just use your calculators, that is perfectly fine. Okay, so when I move the decimal one place to the right, I got a 9x. On the negative 4.1, that makes it 41, and that's equal to 4. Now I'm going to add 41 on both sides. I get 9x equals 45. We're going to divide that by 9, and so x is 5. Remember, you can always go back and check your answers in the original equation. You could take 0.9 times 5 and then subtract the 4.1, and you would see that yes, that does equal 0.4. Okay, so far we've had equations that have a single solution, but some equations have no solution while others have an infinite number of solutions, and an infinite number of solutions we call all real numbers, because that means any number is a solution to that particular equation. So we're going to take a look at this. If you look at x plus 5 equals x plus 7, we can see the x's are the same. We have a 5 and 7. This is going to be a no solution, but it might make more sense if you subtract 1x on both sides, and then that leaves me this statement, 5 equals 7. And that is false. So we call this one no solution, because no matter what number I put in here, I'm never going to get the two sides to be equal. And you can say no solution, or that's also considered a no solution, or the empty set. There's actually another way you could write it, or so on MyMathLab you just choose what kind. I think they usually put the no solution one, the second one that I showed you. All right, so let's look at this other one. I hope you can see at this. If you just take a minute and think about it, no matter what I put in for x, I'm going to get the same thing on both sides, because if I take x and add, or say I put 3 in for x, well, I'm going to get 9 on both sides. And any number I choose to substitute is going to give me the same thing If you subtract the x's, they're gone, right? And you can see that 6 does equal 6. That's true, right? A true statement. And so I'm going to say all real numbers. It's an infinite number of solution because all real numbers are go on forever, right? And then that is it on that one. All real numbers. Okay, on this one we're going to distribute the 4. All right, so I'm going to say 4 times 3x and 4 times 2, so that gives me 12x plus 8 equals 12x plus 8. And so you see, once again, I have exactly the same thing on both sides. I don't really need to do any more solving because I can tell that, hey, I'm not going to be able to get x equals some number. And so this would be all real numbers. All right, I'm going to stop here and then I'll pick up on the next video with this screen that you see right here.